Hello again, everyone. So in this lesson, we're going to learn how to determine the molecular formula from the empirical formula. So let's write this on a blank piece of paper in our notes. And we're going to use some examples to kind of work through the steps. Okay, so take a second, copy this example down, and then we'll go through it. Okay, so in this question, they're asking us how to calculate the molecular formula of a compound that has a molar mass of 30 grams and an empirical formula of CH3. Okay, so the way we'll kind of look at this as you're always going to get two things. You're always going to get the mass of the whole thing. We're always going to get the mass of the whole thing. The molar mass is 30 grams. All right, and we're always going to get the empirical formula, right, which is CH3. Okay, so now remember what these two things are. The molecular formula is the actual representation of the number of atoms in the molecule, and the empirical formula is the simplest whole number ratio. And the molecular formula is always going to be a multiple of the empirical. Okay, so the way you kind of look of it, the way I like to kind of look at it is think of the empirical formula as the building block. Right, this is your building block. And you want to make the molecule, which is the whole thing. All right. So think of it as like a brick wall. All right. Here's our building block. So you want to know, okay, how many blocks does it take to make the whole thing? So what you're given is how much the whole thing weighs and the building block used. Right. So I want to know how many of these building blocks it takes to make the whole 30-gram molecule. So in order to do that, what do I have to do? I want to figure out how much the building block weighs. Okay. So it's the same way as finding the gram formula mass, but I call it the empirical formula mass. Same thing. So step one, determine the empirical formula mass. So same way, we list our elements, C and H, count them up, 1 and 3, times them by our masses that we get off the periodic table, right? Carbon is 12 grams, round to the nearest tenth. Hydrogen is 1 gram. And we tally that all up and we get 15 grams per mole. All right. So our building block weighs 15 grams. Now, the second step is to take our molecular mass and divide it by the empirical formula mass, right? Why do we want to do that? Because that's going to tell us how many building blocks it takes to make the whole structure, right? And that's going to give us what I just call the multiplier, okay? It's what we have to multiply the empirical formula by to get the molecular formula, all right? So we take our 30 grams and we're going to divide it by our empirical formula's mass, all right? So now that multiplier is always going to be a whole number. If it's not, then you screwed something up, all right? So when you divide the molecular mass by the empirical formula's mass, you should always get a nice whole number. If you don't, you probably screwed something up. So take a look. In this case, 30 divided by 15 grams gives us 2, right? So that's our multiplier. So it takes 2 building blocks, CH3s, to make our entire molecule, all right? So now what do? We take your multiplier and you multiply it by the subscripts of your empirical formula. So we have CH3 is our empirical formula, right? So remember, nothing means 1. So there's really 1 carbon, right? So we have 1 carbon and 3 hydrogens in our building block. And it takes 2 blocks to make our whole structure. So we multiply these by 2 and we get C2H6, right? So that is our answer. This is our molecular formula. Right? That's it. So not too complicated, and it's not really a particular formula that's new. It's using what we've learned already, but we're just applying it in a different way. All right. So you really got to know the process rather than knowing a particular formula. And this is the process. All right. So let's try another one and then do a couple practice problems. So copy this one down. A molecule has a molar mass of 180 grams and an empirical formula of CH2O. Find the molecular formula. So again, same thing. So we want to see how many building blocks it takes to make the whole structure, right? And the whole thing weighs 180 grams, right? So what do? Well, first I got to see how much does my building block weigh. So C, H, and O, 1C, 2 H's, 1 O, times them by our masses. Tally them all up, and we get 30 grams per mole. Right? So that's the mass of our building block. Now we want to see, okay, how many times does that go into the mass of the whole thing? So 180 divided by 180 divided by 30 gives us 6, right? Nice whole number. If it's not a whole number, you screwed something up. So it takes 6 blocks to make the whole 180 gram molecule, okay? So what does that mean? I take my empirical formula and I times it by 6. And what do I get? Good old glucose, C6H12O6. All right. So now let's go to page 7 in your packet. So take out your packets, go to page 7. And we want to determine the molecular formulas of these examples. All right. So now when we turn to page 7 of our packet, I only want you to do questions 1, 2, and 3. All right. So do questions 1, 2, and 3. Okay. Skip number 4. Okay. So why don't you pause this video, try out questions 1, 2, and 3, and then we'll unpause it and go over it. Okay, so let's go through these problems. Look at my answers here. Hold on. So number 1. So again, here's our building block. And we want to see how many of these it takes to make a structure that weighs 92 grams, right? So how much does your building block weigh? So NO2, nitrogen is 14, oxygen is 16. So this has a mass of 46 grams. So our building block weighs 46 grams. So then we want to see, okay, how many times does that go into 92? And it's twice, right? So then we multiply NO2 times 2, and we get N2O4, all right? Same thing with the second one. We see how much does CH2 weigh, and then how many times it goes into 70. So CH2 weighs 14 grams. 14 goes into 70 5 times, and we get C5H10, right? 1 and 2 times 5 brings me to 5 and 10, all right? And then the last one, again, same thing. How much does the building block weigh? And then how many times does it go into the mass of the whole thing, right? So in this case, we have 120 grams, and then CH2O weighs 30 grams. So 30 goes into 120 4 times. So we're left with C4H8O4, all right? Not too bad. So think about the concept here, right? Don't necessarily memorize each step. Think about what we're doing. How much does the building block weigh? And then if we know that, we can figure out how many blocks it takes to make the entire molecule. Because again, what is the molecular formula? It's a multiple of the empirical formula. So we think of the empirical formula as our building blocks. How many of them do we need to make the whole structure? Pretty simple, right? See you guys next time.